Today we are taking a quick look at getting started with DMX. So plugged into the machine I have the Enttec DMX USB Pro Mk2 Mark II. Now this is a nice little device, it costs about £160 all in when you include VAT and shipping. Plugs into USB, and then it has a bunch of proprietary Enttec adapters you can buy for it. The one in the box comes with 2 DMX channels, so this can support 2 universes, and it comes with a cable that can output to 2 DMX universes. There is a male, a female, and then on the second universe there is only a female DMX 5-pin connector. On their website you can buy a bunch of different adapters for this. I think there's a MIDI one as well. This will control MIDI playback for you. There's a really nice little piece of software called the Pro Manager. If I just bring that window over, and once it's plugged in you will see DMX Pro. The reason this software is good is it also installs the third-party drivers that you need to access the device properly. It will work, but without the actual drivers it can be a bit funky. If we go into Device Manager, under ports and comms, it should appear as a USB serial port. If you look at it, you can see that it is activated across a USB serial port. We'll come back to that and why that's important in a minute. So what I want to do is just show you this actually working. So I have the device, I've got a really rubbish light from Amazon, it cost about £10, plugged in, it's not getting any signal, and then I've got a DMX 5-pin to 3-pin connector plugged into that. Now I'm just going to put the phone down to plug it in. So I've plugged it into the 5-pin, and on this light we're going to have a quick look at what is behind it. So this has got a digital panel that's got 4 buttons, and you can see I've got it set up to D001. Oh no, I'm not, I've just changed it to D215. Now what this is saying is, according to this very poorly written instruction booklet, user manual, this setting, if it will focus, is D001 to D512 is actually for the DMX channels, and then there's a bunch of other stuff we can go to. You can control it via IP apparently, I'll take your word for it, and then there's a bunch of built-in settings as well you can make this light do. So if I was to change it, for example, so you can see that it's generating light. I think this is actually generating light based on audio, something similar to that. It's got a bunch of settings you can go through to make it do things, but if we change it back to D1, this is set up for DMX, it's listening for DMX, and it's also setting its address to the first channel. So DMX universes are made up of 512 channels, and then you can have multiple universes of 512 channels. For example, this box does 2 universes, so you have a potential of 1024 channels to come out of this. What does that actually mean? So something like this, a light that is set up on DMX, requires at least, you can see here, 1, 2, 3, 4, 5, 6, 7. It lists 7 channels. This one actually has an 8th channel that they've helpfully not included in the booklet that controls the center white lights that this has. So if I flip it over again, it's got a ring of colored lights, and then there's 3 white lights in the middle. There's a channel 8 that actually controls them, not listed on the booklet. So you've got 512 channels in a universe, and each channel can accept values from 0 to 255. So if you've done any sort of computing in the past, those sort of numbers will be familiar to you. They're sort of in a base 2 calculation. So if we were to control this light, we would need to send it 8 channels of information, and then we would set the values of the channels we want to control to different numbers. So for example, if I put this down so we can focus on it more, if I wanted to turn the light on and set it to all red, what I would do is I would pass it, maybe I should draw for this. Hold on 1 second. Let's see how this goes. So I have my light. And that light has 8 chans. Channels 1, 2, and 3 control functions, which means we're going to ignore them. We're always going to pass them as 0. Channel 4 is the dimmer, and then 5 through, that is a 5, yeah, 5 through 8 are color. So we want to pass channels 4, 5, 6, 7, and 8 values depending on what we want to set them to, or what value we want to set the light to. Now, if you give me a minute, I'm going to set up the camera on a tripod, hopefully, so I can focus it on the light, and you can see everything that's happening. There you go. So the camera is set up on the tripod looking at the light. So now we can get started. And I'm going to stay in the Enttec Pro Manager, and I'm going to do DMX send, and I'm going to test that my light's working. I'm going to send it on, I've got it set up on port 1. Oh, and you'll see it strobing. And I'm going to do it from faders. So now I can go back to this theory of I want to have, so I'm going to send it 1, 2, 3, 4, 5, 6, 7, 8 numbers, 8 channels. And then I'm going to control these channels with values. So this means I'm going to do 1, 2, 3. I'm going to do 4, turning it up and down. Now this is the master fader, so it's going to do nothing unless I pass another color. And this channel is red, so all things going smoothly, we should have red light coming out of it. The camera isn't picking it up too well just because of the way that LEDs work, but if I turn down the master fader, you'll see that the color of the lights dim slightly. And I can introduce things like green and blue, and then finally white. And then have a master fader over the top of all of them. Now, higher quality lights will have much more granular ramps. So this one looks like it actually has 10 different stages when you go down. So even though I set it to something like 57, it doesn't actually change until it goes above 70 or so in terms of brightness on the master fade. And the same in terms of color step. It's not able to produce the different shades of light or color going over it. But you can start to see the effects that we can do. If I turn it off and exit the Pro Manager, we're going to look at what we can do with our usual suspects. Something like Touchdesigner is nice and simple, mainly because it has the drivers for the Enttec built into it. So when we start something like this, we can go to DMX out, select the Enttec Pro Mk2, and let's say we want to do a packet per channel. We need to send it enough channels to match what we want to send. And we know that we need a channel, so channel 1, channel 2, channel 3, 4, 5, 6, 7, 8. I'm going to plug that in. Now in theory, if I change something like channel 5, which is red, and then the master fader, we won't see anything. Oh, there we go. So instead of packet per channel, I want to send a packet per sample. It's the difference between sending data horizontally or vertically, essentially. So you could basically have a bunch of universes coming into your DMX and then going to various different controllers, or this controller, for example. If we were to do something like, if we go and look at the operator snippets. So here we go. So this turns values into a range of 512 samples. And then each channel is now a universe. So you could send that to a DMX that is controlling 10 universes. And then that means that you wouldn't need to have 512 chop values in front of you. You can put them in this way rather than that way. I hope that makes sense. But set up like this, it means that we can pass values to the light, which if I bring it back in, you'll see that we can change the value of everything. So I want no red, no blue, no green, but all white. And because of the way that Touchdesigner works, we can change these values. So we can do dim RGB white without the actual DMX light needing to know that. What can we actually do with this? Well, there's something like, you could use it to control a light show if you had slightly more complex lights than this one, by doing something along the lines of, let's say we create some random color. Let's get some color in there and then transform it across the, let's do this. So I'm going to do abs time.frame. Nope. Abs time. There we go. Divided by 1000 to give us a nice slow move. And let's do the same on the y-axis, so it's scrolling. And let's change that to 100. And then we take a top 2. This will give us an R, a G, and a B value, but this will be over every pixel. So if we do something like and take a pixel value, what this is doing is it is giving us the pixel value at 0, 0.5. So it is, I think it's down in the middle bottom. And if we do image, let's include the alpha, input, noise, let's do that one. So now we can set up the white, the blue, the green, and the red. But these are coming in floating points, and this accepts 0s to 255. So what I'm going to do is we're going to put a null on here, and then introduce some maths. So if we put a maths drop in here, do a range from 0 to 255, instantly our light's going to get a bit more excited. Another little thing to note would be that the DMX controller or DMX universes can only operate up to about 40 frames per second. So I'm going to limit how fast my patch is running or my network's running to make sure that every frame it's updating the light, and it should make it a bit smoother. And that is a super quick introduction to DMX in Touchdesigner. Our second favorite is obviously MaxMSP, the classic, the usual, the one that we're always used to. So I'm going to quickly load that up and show you how to access it. It isn't as simple as Touchdesigner because it doesn't have the drivers built in for the Enttec serial communication. So DMX is just a protocol. The actual box is connected via the serial port on the computer. So we're going to access it in the same way that we normally would. So we're going to introduce the serial port, get a printout of what's available. I only have COM3 available, so I'm going to do serial port C. And then going back to the original information that we found in Device Manager, if we go to Properties, Port Setting, I can see that its baud rating is 9600. So I'm going to set it to 9600 as well. Now, rather than the logic of 1, 2, 3, 4, 5, 6, 7, 8 channels, like we were used to in Touchdesigner, we need to include special serial information for Enttec DMX Pro to be able to understand what we're doing. Now, it took a bit of scrolling the internet, but essentially what we need to do is we need to pass the Enttec header, which is 126 followed by 6, the number of channels, chans plus 1 we want to access, values, and then we send the ender message that is 231. So we want our 8 channels to be in here. We need to tell it that we're accessing, in this case it's going to be 9 channels because we have 8 plus 1, and then we need to end it with 231. So to make that, I'm going to do 236, 6, and then I'm going to do $1. I'm going to do zl.join. Will that work? Might do. Let's try. If I plug that in there and then bang that, let's see what comes out. Yeah, okay, so that joins it together. But I need to change $1, which is going to be zl.length plus 1. Oh, that's the wrong. Plus 1. So this is going to get the length of my input, add 1 to it, and then it's going to append it into this message. So down here we'll get 9. And if we were sending, say we had another of these lights chained together, we would then be sending 8 messages plus another 8 messages, so 16 in total. So we would do, it would be a message like this that had loads of different numbers in it. We'd plug that into there, and then you'd see that this would update to 17 properly. All the way up to 513 channels, the maximum that a single universe could hold. Final thing we need to do is append 231, plug that in there, change that to be down there, and test it. Oh, that's all gone wrong. And test it, there we go. So now that is a full message that we can pass to our light by plugging it into the serial port. Now, all things going smoothly, if I send this message, the light should turn off in the video, which we can see it does. But let's make it a bit more exciting and actually do something with it. So if we open up a swatch, let's say, we can look at its inspector, oh, not save it, look at its inspector and change it to old style values. So connecting it up, we'll get 3 values for the R, the G, and the B. If we were to unpack these values into 3 values and then make a new pack that has our 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 values, we could send that into the don't need R. Oh no, that's wrong. Don't need dimmer R, G, B, and then this one at the end is going to be a combined white. So for now we'll just leave that off. Let's make a slider that goes up to our maximum value, that is 255. Plug that in there, and then we are going to plug that in there. No, we're not. We're going to plug that into that, and then that. So now, in theory, this should change to whatever color we have set it to. Let's just have a look at the message that's coming out here, because it's probably wrong. So 9. Oh, there is a problem with our message, I think. Okay, we're back. Just to pick up where we were, it turns out that if you, earlier on we were talking about it being a maximum of 40 frames per second through DMX. Turns out if using serial you send more than that, you can actually crash the serial port. So the resolution was that I just unplugged, restarted everything, and we're back. Someone also gave me the suggestion that earlier we spoke about it being the Enttec header, number of channels plus 1, and then vowels, and then the closing value of 3 return. What someone suggests that we do is, if we do that, and after we've done the header and number of channels, we put 2 spacing values. It passes a cleaner value into the DMX universe, apparently. Not my area of expertise, but it seemed to resolve my problem. So serial C9600, to pick up back where we were, instead of now passing directly the message into the serial port, what I'm going to do is I'm going to set up a Q metro at about 20 milliseconds that'll be slightly slower than a 60 frames per second calculation, but if we do the math, so if we calculate, so it does a maximum 40 frames per second, so that's 1 divided by 40, so 0.25 is what we want. Plug a toggle into that, turn it on, and so let's make our message. So we want 126.6.100. I'm going to pass that into a ZL.join on one side. I'm going to do pack 1, 2, 3, 4, 5, 6, 7, 8 for our values. I'm going to make a slider that has 255, and plug that into our not used dimmer. I'm going to swatch a bunch of colors. I'm going to unpack 000 RGB, and I'm going to set that to R, G, and B. Now, with a little luck, we do that, and then we do ZL.length. ZL.length. See what we're getting out of it. Append 231. Okay, and let's plug that in there. Prepend set. So now we should be working. And we can see that it is. So if I go somewhere blue, or if I go the greeny side of blue, we get no red. If we go the reddy side of blue, we get red. And then depending on the shade, it tries to recreate that color accurately using the values that we pass it. And we then have a slider for it. And that is a super basic look at introducing DMX to both introducing the real basics of understanding what DMX is, and then getting it running in Touchdesigner and MaxMSP sort of fairly quickly. In the next episode, we're going to look at more complex networks. So I'm going to have this light that we see here going to an LED system that I'm just about to put together, and then looking at how to control that, because you're talking that is getting close to filling up a full universe worth of DMX, and understanding how to control that and what that means for the system, and different ways of accessing data and sending data into that. But for now, hopefully this is a start.